Alright, so like last time when we were talking about multiplying and dividing last time we talked about simplifying radical expressions, and this is especially true when we're dealing with new radicals that aren't just square roots, but we're dealing with cube roots, fourth roots, all that stuff. But multiplying and dividing radicals, you just need to know that you're going to be combining the same radicals underneath each other. Now, for the sake of it, I do want to define some stuff. So cube root will be defined as raised to the 1/3 power. Okay, fourth root will be defined as raised to the 1/4 power, and so on and so on. You can kind of see where it's going. Which also means that square root is going to be to the 1/2 power sometimes. You know, it's just easier to just go ahead and write it like that. Okay, so this is the information you're going to need to know. So, for example, if I'm doing, let's say 27, let's do square root. So it would be 27 to the 1/2, and I would be timesing it by 3 to the 1/2. You'd probably be going, oh, that's really scary. Don't worry, just combine them, since they're both square roots, just combine them underneath the same square root. So it would be 27 times 3 to the 1/2 power, which is the square root. Okay? Alright, and then you'll quickly see that it's going to turn into 81 to the 1/2, okay, which is going to turn into 9. Okay, well, actually, I would say plus or minus 9. Yes, do plus or minus 9. It just saves you a whole headache when you're dealing with this stuff. Okay, so in other words, when you are multiplying and they both have the same radicand, you can combine them underneath the same radicand and just go ahead and do the operation and work on it that way. Okay. All right. Now, what if we were dividing? Let's say we had 15 to the oh, excuse me, 1/3. All right, and then we divide that by 5 to the 1/3, and you're probably sitting there going, oh my gosh, cube roots, I'm so scared. Don't be. They're not that scary, because what you can do is, since they both have the same radicand, you can just go ahead and divide 15 divided by 5, raise that to the 1/3 power, and that will equal 3 to the 1/3. Okay, so that's pretty simple right there. Now, once again, if you are dealing with x's and y's and everything, please understand that if you're dealing with the same radicand, try to do some division. Try to simplify it and then work your way out. Now, this works the same way for if we had like variables. So like, let's say we had x to the 4th times y to the 2nd times z to the 6th. Okay, all raised, and let's say that that was being cube root up there. You could actually approach this problem several different ways. Okay, now variables and square roots and cube roots and all that stuff are a little bit trickier, so you just have to stick with it. Okay, so this would be x to the 3rd times y to the 5th times z to the -2nd. Raise that to the 1/3. Okay? Alright? So you could do this one of two ways. Now, if you notice, this is now, instead of a cube root, it's now a 1/3 power. We could distribute that power to each one of these in here first, if you'd like. So same thing here, here, and here. Okay, or you can go ahead and divide them, which in other words would be subtracting the exponent. So first off, I'm going to show you what happens if you distribute it. So on top I would have x to the 4/3 times y to the 2/3 times z to the 6/3, which just turns into z squared. Okay, so that's all on top. All right, and then on the bottom, that would be x to the first, because 1/3 times 3 is 1. Okay, y to the 5/3 times z to the negative 2/3. Okay? All right, and then I could actually work with them from there and just go ahead and do subtraction and everything. So this would just turn into, let me see, subtraction, that would be 4/3 minus 3/3, which would be x to the 1/3. Okay, the y's, you would minus that, so that would be times y to the negative first, and then that would be z to the let me see, 2 minus negative 2/3. When you minus a negative, it's going to turn positive, so it's like 2 plus 2/3, which would be 8/3. Okay, so this one's pretty straight up and simple. Now you would need to simplify it out and just work with it as is. So this would be x to the 1/3 times, well, actually in front would be z, and it would be z, would be absolute value of z squared, which in all actuality, what you're doing is you're dividing the 3 into the 8 and getting the 2, and there would be 2 left over, so that's why there would be a z squared left, or z to the 2/3. Okay. Alright, so it would look like this, and then on the bottom we would just have y, because it's a negative exponent, so we need to move it to the bottom. Okay, well, z squared and z, absolute value of z, do the same thing, so this would just turn into z squared, so you don't need that anymore. And then you could have cube root of x times z squared. Okay, so this is another way of doing this one and just writing it out. I mean, once again, there's so many ways to actually do this stuff. Okay, you could do that one in the beginning, or you can do the subtraction first and then do the cube root second. So you could actually do the subtraction first and go, it would be x to the first, and we would have that in parentheses because everything would be division, and then we would have y to the negative third. We would have a times sign in between, and then a times sign of z to the 8th, and raised all to the 1/3 power. Okay, and then you would distribute the 1/3, and then you would end up getting all of this. Okay, so there's a couple different ways to go about doing this and just actually working it out. It's totally up to you how you want to do it, but just remember, when you're dividing, you want to always rationalize the denominator, so you want to multiply top and bottom by whatever's in the bottom fraction. Okay, so for example, if you get stuck and you're like going, oh, I can't do this, like for example, the square root of 21x to the 10th, all divided by the square root of 7x to the 5th, Okay, I would probably say don't try to multiply top and bottom by the square root of x, 7x to the fifth. I would just say divide the top and bottom and get the square root of 3x to the fifth. And then that would turn into x squared times the square root of 3x, which would be the leftover portion of that. Let's move that over a little bit. There we go. Okay. Right. Now the reason why I didn't put the absolute value bars around is because I got squared, and squared takes care of it. Now if this was x cubed, I wouldn't need to put the absolute value bars around it. Okay. All right, but that's it for multiplying and dividing radical expressions. So please take your time on it and just remember your rules, especially for working with different type of roots. All right. Bye.